Welcome to the demo. This demo is about a very simple test automation framework that I have written in Python, and it is capable of communicating with TestLink. So the TestLink is the main driver for running the automation on the framework. In other words, the automation framework picks up the test plan from the test project that it wishes to run, gathers all the information from TestLink over XML RPC, and then runs the respective tests. So here is the basic structure of the automation framework and how it extracts data from TestLink and updates data. So I'm just going to draw some block diagrams, explain how the test plan and the test specifications have been organized in TestLink. That is how I have done it, and then we will move on to the demo. Right, so right now I will just be drawing some diagrams for you to better understand how the framework operates later. Okay, so I have TestLink here. Excuse my drawing. TestLink is of course running on Apache. What I have here is my Python program, which is the test automation framework that I have written. So I'll just call it TAF, in other words test automation framework, and how it communicates is over XML RPC. Okay, now the overall plan for testing is I have a test project in TestLink which I have named as evaluation 101, right? So this is the name of the test project, _101. Under the test project, I have actually created two test specifications. Which are called strategy 1 and strategy 2. I'll be showing all of that in TestLink once I open TestLink. In fact, it's already opened. Once I open TestLink, I'll be showing all of this. But this is just to explain the flow. Under strategy 1 and strategy 2, I have created a few test cases. So the names of those test cases are, by the way, these are dummy test cases. They don't have any steps. Okay, so there are 3 test cases: case 1, case 2, and case 3. Under strategy 2, we have 4 test cases: case 4, case 5, case 6, and case 7. Okay, now I have created 2 test plans, test plan 1 and test plan 2. Okay, now the test cases that I have added as part of test plan 1 are case 1, case 3, and case 5. Okay, test plan 2 covers case 2, case 4, case 6, and case 7. So this is the overall arrangement of test plans and test strategies. Now, by the way, the test cases that I have created have been modified slightly, in the sense that I have added 3 custom fields in these test cases. Okay, now those custom fields are named as test script revision, and test data. That is these 3. Okay, now I will come back to as to why I created those extra fields. those fields are required for the test automation framework. Okay, how I actually conceptualize the test automation framework is like this. Every test case will have a test script associated with it. So if you come here, the test script revision and test data, basically every test case has a test script, and the name of that particular test script is stored in those custom fields in TestLink, right? So the case 1 will have its respective test script in Python, case 2, case 3, similarly for the rest of the cases. Okay, and it will also contain the respective name of the data file, that is the test data file that you have. And I'm going to show the custom fields when I actually go to the TestLink URL. Okay, so the logic of the test automation framework here is, when I start the test automation framework, I put the test project name and I enter the test plan name. In this case, it's either, as you can see, it's either test plan 1 or test plan 2. If I put these two entities into the test automation framework, the test automation framework will extract the complete information about all the test case IDs with respect to test plan 1. For example, so if I pass test plan 1 to the test automation framework, it will make RPC calls to TestLink, and it will actually find out that case 1, case 3 and case 5 are a part of test plan 1, and it will find out the test case IDs that are associated with the test cases, because information extraction or information update mostly happens in TestLink using the IDs, and there are APIs actually to fetch the IDs for the test cases. Not only for the test cases, but we will need IDs for the test plan, test strategy and everything, which is completely taken care of by the test automation framework. So once I pass these two to the test automation framework, it extracts all of this and it actually creates a data structure in the test automation framework. So the data structure actually looks like this. The data structure is basically an array consisting of two elements. One is again a dictionary, and the second is the test plan ID. Okay, now if you want to know about the dictionary, is organized in this fashion. So I'll just go, I'll rub this out, and I'll rub this part out, and I will show the structure of the dictionary here. So the dictionary that gets created actually has all the artifacts, all the information that is needed to run the test, to execute the tests. So the dictionary takes up the test case IDs, and from the test case IDs and the custom fields that I spoke of, it extracts the test script names from TestLink. Okay, and it fetches those test scripts corresponding to those test cases. So basically, I'm not using Git here, but generally the test case or test script development will happen in Git. So naturally, when Git comes into picture, we will do a Git pull and we will have our test scripts available in Git. So now the scripts corresponding to each of those test cases will be pulled by the test automation framework, because the names are stored in the custom fields in TestLink, and it will execute the scripts. I'm not showing any data driven test automation here, but then again I have kept the name of the test data file here, so in case somebody wants to do some data driven test automation also, that should also be possible. I'm just running the bare bones test script here. So what basically happens is, as I had mentioned, Here I have a dictionary, and here I have a test case ID, which is the final product of one of the classes. So that's half the work done basically. So this structure again goes into the execution class. But anyway, uh, the point I'm trying to show here is, so now we have a dictionary. So the dictionary actually is structured like this. It has a test case ID. It has a, if I can draw your attention here, it has the test case ID that is a part of the particular test plan that I have passed to the framework. And then there is another dictionary, or see, you can consider the dictionaries as hashes if you're not familiar with Python. So, and inside there is an array of hashes, and these hashes contain some artifacts. Now these artifacts are like the test plan ID. This is the Python file corresponding to the particular test case, right? This is the data file corresponding to the particular test case. This is the test case revision, and this is the test case name. So similarly, we have another test case with test case ID 9. We have another test case with test case ID 17. So this is a data structure that is being generated or produced by this class. Okay, that is TestLink data extraction, right? Anyway, more on this later. Once that structure is generated, that structure is passed to the next step. That is, the structure is passed to the second class, which is the execute test plan class. So what execute test plan class does is, the main method in that class is the run script method. So basically this picks up those scripts corresponding to those test cases and it runs. So I will be showing all this the one script actually in the end, but that's what happens. So when you call it as a framework, basically what happens is, as I showed you, this data structure that is being passed out of the first class, the framework iterates over these test IDs because these are the keys, right? So these are the keys to the class. So the framework will iterate over this key, and this key uh, as a Python loop, for loop of course, and it will extract, it will go by the data that is mentioned here, pick up this string, let's pick up this file name, and then execute the script. Okay, so that is what happens in the second class. Of course, creating a build for execution in TestLink and logging. So the logging is also an interesting function. I have added a timestamp here. Logging is also possible with the datetime package. So the log looks more comprehensive. So once the test result is generated, the log files are generated, and the result of each of these test cases are loaded back into TestLink. This is what the test automation framework is about. No error correction is being done. So there's zero error correction. If you see some real test automation frameworks, the test automation frameworks are much more involved and of course complicated, because there's a lot of error correction that happens. There are a lot of error conditions that that one may come across. For example, searching by a test plan name. What if that test plan doesn't exist? Or what if I'm trying to search for a custom field that doesn't exist? What if there are certain errors that are generated by XML RPC? We need to interpret those errors and take the necessary corrective measures, right? So all of that is not being done here. This is assuming that everything is present, everything is available in TestLink, and just show a very basic test automation framework as to how the flow is. So now I will move to TestLink, okay, and I will show this layout, and then we will run the code. So I've opened up TestLink now, and as you can see, uh, the test project that I'll be working on is evaluation 101, as I had spoken about before. To know more about the test project that I created, you can come here and click on it. Nothing much, nothing fancy. It's evaluation. The name is evaluation 101, and I've just put in a comment saying this project will be used as a demo. Uh, Coming to the test cases I have created, let's go to test specification. Here are the 7 test cases that I have created under 2 specifications which I have named strategy 1 and strategy 2. So this is test case 1. Now in test case 1, it doesn't have much, not much is written about the test case, because this is just to prove the concept. I would specifically like to show the 3 custom fields that I had created and that I had spoken of. And these are the 3 custom fields. So I have named them test data file, test script name, and test script revision. Now, as you can see, the test data file name is case1.xml, test script name is case2 case1.py, and test script revision is 0.1. However, I could have named them anything else. Okay, this could have easily been something else. This could have had some other name. Of course, whatever the names are here, those names are going to be extracted into that data structure that I had discussed about earlier, and the corresponding Python file would be picked up and executed, right? So here are the test cases that I have created. Likewise, case 2 is also a dummy test case with the same custom fields with different names. Similarly for case 3, case 4, case 5, case 6, and case 7, right? So like I said, they don't contain much. They don't contain anything. In fact, no steps, nothing. Of course, these test cases will also show which test plan this test case is a part of. As you can see, this shows that it's a part of test plan 1, case 2 is a part of test plan 2, so on and so forth. So I will show the test case grouping under the test plan shortly. These are the test cases that I have created. Going back to home, if you come here to add remove test cases, here you will get a better idea of the test cases that are being added under each test case, right? So if I want to see what are the test cases that I have under test plan 1, it's standard TestLink. So I go to strategy 1, that is the first test specification, and I see that under strategy 1, case 1 and case 3 are included, and under strategy 2 I have case 5 included. So under test plan 1, the total number of test cases that are included grouped are case 1, case 3, and case 5. So if I want to execute test plan 1 from my test automation framework, it will execute the scripts corresponding to case 1, case 2, and case 5. If I go to test plan 2, similarly, you can see that test plan 2 has case 2, case 4, case 6, and case 7, right? So these are the test cases that are included under test plan 2. So my logic here is, I will, as I said, as I discussed before, I will pass the project name and the test plan name, and the corresponding test cases should be executed and reported back to TestLink, right? So let me go back to home once again. Okay, and so if you see the builds and releases section, here's a build created. This is one build that has been automatically created by the test automation framework, because to create to run a set of tests, a build needs to be created for reporting purposes, right? So this build has been created with a timestamp automatically by TestLink, and then some test case results have been uploaded as a part of an old test run which I had done. To ensure that the test automation framework is really running, I would delete this build, right? So this build would be deleted now. So once this build is deleted, the test link contains nothing, right? So it's completely blank. So now I will run the test automation framework. Okay, and I will show that the information is getting extracted, and uh, the test case reporting is happening as per expectation. Once that is done, I will quickly run through the code, and I will try to explain the logic of the uh, Python file that I have. Okay, now coming to the execution part. So I will show the execution of the test automation framework on a Ubuntu virtual machine, on the same Windows machine actually. So this machine has its own IP. Which is 192.168.2.5, and of course it's getting the IP from my home router. And what I'm going to demonstrate here is uh, I'll run the test automation framework from the virtual machine, that is 192.168.2.5, and the TestLink and the Apache server is on my base machine, that is the Windows machine. So I will be accessing the TestLink from here to the base machine, and I'll be running the test automation framework. Okay, so let me explain the scripts here. These are some log files from some previous test runs, so I'll just be deleting them. So to begin with, this is going to be how it is going to look like. So access underscore testlink.py is actually the test automation framework Python file. These three files that you see adjacent to that are the test scripts. Okay, these are the test script. If you see the names of the test scripts, these names you will see are associated with the names that you saw in the TestLink custom fields. Okay, so it's not necessary that these files need to be here. For brevity's sake, for this demo, I have written the framework in such a way that it only picks it up from here, but it could be anywhere, right? It could be in some in a Git repository elsewhere on the machine, from where these files could be accessed. Now these Python files or these scripts actually need to be developed separately in the sense, before actually plugging them into the test automation framework, they need to be developed separately. Now since these files are being run using the exec command in Python, uh, all the errors that come up in the test scripts are not directly apparent. So a separate SDK or separate development environment needs to be created for these scripts to uh, for development and debugging purposes. So I have not written any SDK or here. So basically, if I open the script, what you will see is basically, since I'm using an exec call, these scripts are plugged into the test automation framework, and they run as a part of the framework, right? So this code can access all the methods of that particular class in which it is called. So that is why you'll see calls like self.log result or self.send command and self.log result, so on and so forth. These uh, calls that you see here uh, all belong to the same class, that is the execute test framework class. Okay, so one advantage of scripting like this is, see, as you can see, no setup is required, because you can just write the APIs, make the calls, and the test script gets executed. The downside is it is not possible to develop and debug this script outside the test automation framework until and unless we write a kind of an SDK to develop these scripts. So basically the SDK is nothing but a wrapper around the script so that we can run these scripts standalone within that SDK. It just, the wrapper is going to supply it with all the classes that it needs to run, because otherwise where are we going to develop these scripts to see the outputs? Because the scripts are not going to be as simple as this. It's going to be a big emulating a big test case, and with multiple steps, so on and so forth, right? So that's a discussion for another day. So I just wanted to make that point so that if the question arises of how these scripts are developed, it is developed in a completely different environment, not this one, right? Okay, so coming back to the folder, uh, this is the Python file that I had shown previously, where for demonstrating some data structure. Let's briefly open it so that I would like to show you a few things. So this has something called as a server URL and dev key. These are necessary for accessing TestLink. Okay, and uh, I will first show the test run, and later on I'll come to explaining what the logic behind the script is. Okay, so let's go to a terminal and get inside the folder. So I'm using Python 3.6 here because of the XML RPC client that I'm using. This is not there available in Python 2.x, right? So I'm just using Python 3.6 on both my virtual machine and the base machine, right? So okay, and I'm going to call the Python file. So yeah, there's something else that I need to show you, which will demonstrate the idea of what I'm trying to do here. So if you can see, I'm creating an instance of the first data extraction class. This is the class which, as I had mentioned previously, this is the class in which if you pass the test plan name and the test project name, will give you back the data structure which is going to be used for the test execution, right? So if you notice, I'm passing evaluation 101, which is the project name, and test plan 1. This could be test plan 2 as well. So I have two test plans, test plan 1 and test plan 2. So I'll just show it for test plan 1. So I'm collecting the data structure here, and I'm just printing it out to show that it's indeed generating a data structure. And then I'm passing the same data structure to the I'm creating an instance of the execute test plan class and passing the data structure and then running the script. Okay, so this is what is going to happen. So basically, out of the project name and the test plan, I'm going to get a I'm going to run the test. Okay, so Python 3.6, and now I'm going to give the Python file name. Okay, and I'm going to execute the code. So all of that is happening in the background. It's connecting to TestLink, it's grabbing all the data, and it's running the 3 test cases, right? So now all the 3 test cases have been run. If you see here, it has just to show you the the data, the data structure that has been formed. As you can see, I have three test IDs that has been created, that is 5 and 9 and 13, and the test plan ID, the test case, the test script name. This is the test script that has been picked up, and the XML, and 0.1 is the version, so on and so forth, right? So all this data has been fed into the second instance of the class, and that has actually run the script and produced the results. Let us have a look at the logs that are being created. So if I see the first log, what you will see is I just gave a I just so you can see the timestamp here, right? So this tells you that it's today's date. It's 9:18 p.m. and it's kind of going into the milliseconds also, uh, milli or microseconds. But this is basically the timestamp, and I if you saw the case one, I actually just printed some value, and I sent a command to the console of ifconfig just to get the, I mean, these test cases don't mean anything, right? So here you will have a lot of decision steps to take, whether to pass or fail the test. You call the ifconfigure, probably you are looking for some specific value in that particular string based on which you are going to pass or fail the test case. All of that I have omitted. The only thing I have done here is I have tried to call ifconfig to send command. So the two APIs that I have created for, there could be many. Generally, there are many more helper APIs for running these test cases, but just for now, I have just created the log result, which is actually populating the log file that you saw, and send command is what actually sends a command to the console and gets the result back. So when you actually call log result API, it logs the value in the log file with the timestamp, and then this is the API which I'm calling to report that this test case result back to TestLink. Okay. So when I open TestLink, you will see in the test run, this particular test case has been failed. When I run test case 2, you will see that it will produce a very interesting result, because test case 2 in this case does not have uh, any uh, any test scripts associated with it, so it is just going to show error. So anyway, if you see the second log file, if you see the second log file here, case 3.log again, just checking if a log file gets generated, and then case 5 is nothing, because case 5.py has nothing, so it's just a dummy. So it's this print prints in the console, so this is not the print in the log. Okay, so that's why you don't see anything in the log file. Anyway, now I'm coming to the TestLink, and we'll see what changes have gone into TestLink now. Okay, so here are the log files that have been created locally. Now we'll see what changes this script has caused to TestLink. Let's open up TestLink. The first thing that we see is it has created a build. Now if you see the timestamp, it is 9:18, and we saw a timestamp in the log files. If you remember, it has created this build around that time, obviously, right? Because first it created the build, and then it did the test run, right? So if I go to home, and now I'll try to see the test results. Okay, so let's go to test reports and metrics. Okay, and then we will go to test result matrix. Now if you see here, only one build was present here, right? So this is the build name, that is the build that you saw. In that build it says that 2 test cases were run for strategy 1, that is the test specification strategy 1, and 1 test case was run for strategy 2, which you saw previously. And as you can see, case 1 I had failed, so that report is showing up here. Okay, so it is actually logging the failed and passed result into this TestLink suite, right? So this shows a complete execution of the test automation framework. Next I will run through the code and show you what logic it follows. Okay, before I move on to the code, uh, I want to make some correction about what I spoke a while back. I had said that test case 2 does not have test cases associated with it. What I meant to say is test plan 2 does not have any test cases associated with it here, because test plan 2, as you know, are associated with test case 2, test case say 4, 6 and 7. So no test cases have been written for test plan 2, right? So let's do one thing. Let's run the test automation framework for test plan 2 and see what happens. So what I'm going to do is, instead of test plan 1 here, I'm going to change it to test plan 2. Okay, and I will run the same framework in the terminal. This time I'm looking for all I'm looking to run the test cases under test plan 2, right? So I'm looking to run the test scripts under test plan 2. So let's see what happens. Okay, so as you can see, it extracted the test data structure correctly. For example, the test case IDs and all of this, you would see these are what you saw in TestLink, right? All this information, the middle three, that it extracted correctly, but then it could not execute the scripts because case 2, case 4, case 6, case 7.py is not present here. There's a bug in the script though. It's anyway creating the log files. Well, that it's not supposed to do. So if I did not have test case 2, the log for test case 2 should not get created, right? That's so this is the bug. I mean, did not I did not fix it because it's not needed here, but then that's something I wanted to show. Okay, now coming to the code of the test automation framework, right? So we have come here before, but this time I want to explain the structure of the code. As you can see, in the top I have imported some packages. One is XML RPC .client. This is the main package that communicates with TestLink. Now there are other more direct packages available in Python which can talk to TestLink, like the package name is TestLink itself, but I did not find the right methods in that package to extract data from the custom fields that I created, right? So I checked out the sample files and I could not find it, so I fell back on the base XML RPC method. There were some examples in the in the TestLink folder itself, and so I then derived the API calls from those example programs and wrote the program here, right? So another package I imported was the time date time package. This package is used for the timestamps that you saw in the log files. This, though I included, is not used here. It can as well be omitted, and RE is not used. Okay, this one is used, that is from subprocess import popen pipe. This is actually used for firing commands to the shell, right? So popen is the process, popen is the call. So this is necessary. After that, I have 5 variables here. So these are global variables, of course. So I have the server URL, which is the URL where the XML RPC PHP file is residing, right? So in TestLink, the dev key is a key which needs to be generated to communicate with TestLink. So that needs to be generated in TestLink from the project, basically. Okay, so I generated the dev key and in TestLink, and this is the dev key I use to communicate with. This, what you see here, is the other field names in TestLink, like test script name, test script revision, and test data file. If you see, these strings are exactly the field names that you saw in TestLink. Okay, same name, this should not be different. Now comes the 2 main classes which do the job and do the work of creating the data structure and executing, right? So one class is TestLink data extraction, and the other class is execute test plan, right? Previously I had actually mentioned the class name slightly differently, but it is execute test plan, right? So we'll check out the different methods of the classes. So in TestLink data extraction, of course, there's an init phase which is extracting the URL from the global variable through here. This is where the actual connectivity is happening with TestLink. Okay, so this is the XML RPC client, XML RPC call. Okay, and this needs the URL. Okay, right now here the dev key is not needed. This just establishes the connection, right? And then I have quite a few variables here. So if you see, I have test project name and test plan name right here. So basically these two are the calls that I will, when I create an instance of the class, these are the 2 parameters that will be passed. If you see below here, test evaluation 101 and test plan 1, right? So these are the 2 parameters that go into the create instantiation of the class. Okay, because these are the, so I could have done it in a different way. I could have passed it to a method and done it. So you can do it anyway, but this is how I chose to do it. So here are some other variables that I have declared. Now these variables are declared for making them global within the class, because these variables get shared among methods in the TestLink data extraction class, right? So this is the main method which actually creates the structure that we saw during the test execution. I will come to that. This is just there, it gives you an info about the whole project. Okay, this gives you the, okay, what this gives you an info about the entire XML RPC version and things like that. Okay, this one actually tells you in TestLink how many projects are there. Okay, so these two I am not using, even though they are there, because I picked these two up from the sample files. Rest are all written by me, so I've just left them there. Now get test plan ID. So basically, I had mentioned previously that anytime that some operation is tried out on XML RPC, that is, if we are trying to extract some data or we are trying to write something into TestLink, mostly it happens on the ID of these artifacts. That could be due to the fact that eventually all these artifacts are pulled out from the MySQL database in the backend, right? So probably these IDs are helping to extract the data from those tables. Probably. I have not had a look at the PHP file so deeply, so I cannot be sure about that, but most probably that is what is happening. So now get test plan ID, what happens is, so the send variable that you see here, what it basically does is, this is the format in which the data needs to be sent to the sent over the over the Ethernet to TestLink, right? So these are basically dictionaries. So as you can see, I have what they contain. So it contains the dev key that you saw on top, the test project name that was passed to this function, and the test plan name. Okay, these three uh, elements, entities are passed. Now this is the call for getting the value, which is from TestLink. Okay, now getting the value means this, whatever you see here, get test plan by name, this is the call that is being made, and if you see that, just if you see the corresponding call in the PHP file which corresponds to this XML call, you will see that the same this method is available there also, right? So basically this call is actually broken up into XML format and sent over to the server, that is TestLink. It's sent over to TestLink and the data is extracted. So this invokes a particular function call in that PHP file, and that particular function call extracts the data that we are looking for. In this case, we are trying to get the test plan ID. What is returned is not a very straightforward data structure. It just does not return the ID straight away, but it returns an array of hashes again. So okay, so array of dictionaries or whatever you call it. So that is the reason we need to index it as an array, and then which is of course the index 0, and in that particular array, ID is the ID we are looking for, ID is the value we are looking for. So this answer, so we return this. So now get test project ID. Now this one similarly gives you the test project ID, similar to plan ID. So we know the names, but now we need to know the IDs corresponding to the names, right? So similar kind of a call is made here, and again, as you can see, the response here is pretty straightforward. It's a direct hash. So what you get back in response is just a direct hash, and you get something, and the prefix. Now the prefix is, if you open TestLink, you see this eval here. So eval is the prefix that I set for evaluation. This prefix has been set by me only. Now this goes into the prefix value for that particular project, right? So that I want to extract here, right? So prefix is that. Okay, get test case ID is again, this is quite an involved call, though it looks simple. This one actually lists all the test cases in the test plan, and it lists the test cases with the test case IDs. Okay, so what are we passing here? We are passing the dev key, of course, and we are passing the test plan ID. Now the test plan ID, see, it is internally calling the get test plan ID API here, right? Because because it needs a test plan ID, right? So it's just calling that API from here and feeding the value to the XML call, and it is getting a response. Now the response is not straightforward. The response is a dictionary which holds all the test cases, which is this is the data structure that comes back when I try to uh, get the test cases under that particular test plan. So as you can see, test case ID, and it has test case name, and then test case ID, it's TC ID, test case ID are the same, TC version, external ID, so many values are here, which we will need. Many of these values are needed. So this is a kind of a, this is a dictionary of an array of a dictionary. It's a very complicated data structure. Okay, so that's what is happening here. So the response is actually the response. When you say return response, the response looks like this. Okay, it's this kind of a data structure is actually returned back, okay, to the caller. Fine. Now when I come here, so get test data structure. So basically what happens is this call that you have makes use of all these APIs internally. That's why I have put them under underscores, just to signify that these are private. So what basically happens is I get the project ID from here only, below. So I'm calling that project ID function. Okay. Then getting the test case ID. Now this test case ID, as you see here, get test case ID, it is that complex involved structure, this one. Okay, it's not one value, it's a big data structure. And then test data structure is the data structure that I want to build. Okay, now what I mean to say is test data structure is the structure that this function is supposed to return. Test data structure is this. Now this is returned by the API. This one is built by me. Okay, so what happens here is so I just create an empty dictionary because I have to populate it, right? And then I get the test plan ID. Okay, so again from some API below. Now as I said, test case ID is not a straightforward entity, right? It has keys, as you saw. These are the keys I'm talking about. So these are the keys. Okay, 7 is one key, and then you have goes in, and 11 is another key, and so on and so forth. Okay, and whatever you find between 7 and 11 are the dictionaries and the arrays that carry all the information for this test case. Okay, so what I'm doing here is now custom field array. Okay, custom field array is again one array that I'm creating. Okay, this is something that I'm creating because of, I'll show you, because of this. See, if you see this array, and whatever is contained within this array is what I'm filling in. So when I'm iterating over the keys, I'm getting this, okay, for each key, and when I'm creating the array, these are the values I'm pushing into the array. Okay, so what's happening here is so custom field array append test plan ID. So what I'm doing is now I'm adding the values one by one in that array. So I am just making an array, I'm just preparing an array to be pushed into this dictionary later. So first I'll make the array, then I will place that array in the dictionary with the respective key. So if this test plan 1 has 3 test cases, there will be 3 test IDs, that is 3 keys with 3 arrays. That array will contain the fields that I extracted from the custom fields, the test plan ID, test case name, so on and so forth. So all that activity is happening here, right? So I just do an append of test plan ID, and then I do test case external ID. Okay, so this is little tricky. Maybe I'll explain it later. So what I'm doing is I'm appending 3 strings. So basically test case external ID cannot just be extracted using the test case ID. You need to have the project ID followed by a hyphen followed by the test case external ID. Now test case external ID is extracted by the key, of course. For that particular, the key is the test case ID. The zeroth array that follows it, and in that zeroth array the key is the key value is external ID. So this whole thing is going to bring out, so it is going to be like, so the result of this is going to be eval dash, okay, and a number. So in this case it is going to be, for example, test case external, it's going to be 2, so eval dash 2 probably, right? So this is the value I'm saying. So it's 0th array and external ID, so I'm picking this value 2. Okay, once I pick the value, what I do is I again then I pick up the version, in a similar fashion I pick up the version, and then I pick up the test project ID. Okay, now what I'm trying to do is I'm sending all of this. Okay, I'm sending, so why am I sending all of this together? I'm sending all of this to get the custom field value. Okay, now the custom field has 3 values as I showed on top, right? So first I appended, so one append has happened here of test plan ID, but then I need to get the custom field values, right? So the custom field values are test script, test data, and test script version, right? So what I do is I extract those values. Okay, I extract those values one by one. This is within one iteration for one key. I'm extracting those values and I am pushing them into the array here. See, all the appends are happening here. Once the append happens, and then I'm also appending the test case name for if I wanted to use it, but I'm not using it anyway. Then what I'm doing is, see, this step is where I am putting the key of that test case. This is the test key, this is the test case ID, and I'm pushing the array in to that particular dictionary, right? So now I have the dictionary with a key and an array associated with that key. Okay, this process repeats for 3 times in case of test case 1, right? Because there are 3 test cases, and this kind of array, this kind of a data structure gets created. Okay, so this is the call I make. This is the first class. Okay, this is the call I make. I print the call just to see how the data structure. Now what I do is, now what I'm returning from there, the function that I'm returning from there, if you see, I'm returning two values. One is of course the entire structure that I created, and then I'm returning the test plan ID. Okay, I will tell you why I'm returning the test plan ID separately. It makes my life a little easy here. Fine. So that value is coming and getting collected here. Now I am going into the execute module. In the execute module, I am feeding in what I got from here. That is, I am feeding in back 0 and back 1. Back 0 and back 1 happen to be the data structure that I created and the test plan ID that you saw. Okay, and then I am doing a run script on that particular instance. The run script is again one API one method within the execute test plan class, right? So if you see execute test plan again, similar similar variables have been declared here, XML RPC class. So this is again doing the connectivity with the TestLink. Okay, I have the dev key, I have data struct, and I again here some global variable share between multiple methods. Okay, this is done because if you see in the script that I have, if you see in the test script.py, I have kept the calls as simple as possible because the test script is not supposed to know what log file it is a part of. I mean, the timestamps of the log file, neither is it supposed to know uh, what test plan it is executing for. All of that should be taken care of by the test case. The test script only will have a test name, and the name and it's a job of the test automation framework to pull the right test script. So the test script does not have where it is not upon the test script to actually decide which log file to write into or which test plan ID to write into. That is all automatic, handled by the framework. This is the API which is creating the build, right? So again, it's the same method that is being being followed as the previous class. These are the function calls. So every API that you see will have a different function call. This is very important. This is very important, and the sent part is the dictionary, or the values that the function call. Now if you go into the PHP file that corresponding to this, there are a lot many more parameters that you can pass. Some of them are optional, many of them are optional, so I am just passing the parameters that are absolutely necessary. I'm not passing everything, right? So just to simplify things. And then I have the log result. So in the log result, I'm creating a timestamp from the datetime package. It's pretty simple. I'm just not doing any string. I'm not doing any cleanup of the string or any kind of string manipulation here. Just plain whatever I'm getting. Now string to print, I'm just restructuring it. So now the log file is being called by this log result, as you saw previously, was generally called, not generally, it's every time it is called by the, in this case it's every time called by the test scripts, right? So the log result should not contain too much information, right? So it's just self.log.write. So but there is a trick here. This, the self.log.write, and this that you see, the self.log, this part, okay, this is actually a file handle, okay, which is this. So self.log is basically a global file handle, okay. It doesn't look to be so, but it is so. And once I come to the run script phase, you'll get to see why this is necessary. So so basically it is writing into the file handle that has been opened by run script, okay. So I don't have to, in the log result I really don't have to, so the script does not have to bother about where it is writing. That file handle is opened by run script and it's globally open, so the log result can just pick it up, and wherever it writes into the right file. Yeah, and of course I'm opening this in the append mode, okay. This is interesting. This is where the test case results are going back to the TestLink database, okay. So this call has of course dev key is absolutely important. It goes everywhere. Test case ID, okay. So this test case ID is, again, it's a global which is picked up from the run script. Test plan ID, again, it's picked up from here, okay. then you have the build name, okay, which is again picked up from here. So the test case test plan ID is picked up from the function call itself, right? From, I pass the test plan ID into the second executable, right? Second instance of the class. And then you have self.buildName, which is again passed from here, and then this is the main thing, okay? So self.status. If you see, I don't need to this is also another call that needs to be made from the test script, right? So that is script, again similar to logging, this test script does not have to bother about where it is sending the pass fail result. The test script doesn't need to know, right? The test script, what does it do? It just sends the pass fail result. All the information, the test plan ID, the build name, and the test case ID, especially the test case ID, are being supplied by the rest of the class, right? So if you see build name here, the build name is being supplied by this. This generates the build name here in the run script. Once I come to the run script, things will become clearer. And then you have the self.create build. This is the call that is being made to this, right? So create build goes with test plan ID and build name, right? So that build name comes here, okay, when you're doing a reporting. So reporting has to happen under test case ID, test plan ID, and the build name. And then you have the run script, which I'll come to. And then it's the same send command. Send command is also called from the test script. It's a simple popen command that I have written. So it's nothing fancy about this. It's a standard popen that Python uses. I'm just passing this from the script using a self send command, and I'm returning the values. Like if there is an error also, I'm capturing that. If there is a standard std out value also, I'm capturing that and returning it to the script, right? Now coming to the run script, which is the main part of the class here. Now I have the so here what happens is I just do a run script. After I pass those values, I do a run script. So in the run script, what happens? Run script works with this data structure, okay? So what happens? Run script first creates a timestamp, okay, and it creates a build name. Now this self.build name, it's self.build name because the build name is global for it to when report TC result is called from any test script, the build name is global, so it can pull the build name from there. So the build name is already set by run script, and this global value is pulled in, right? Then I do a create build. This create build is actually called to this function. As I said, this creates the build actually in the TestLink. Now I go iterate over the keys of the data structure, right? Data structure means the data structure that I have been passed, that is this, okay, this one, yeah. So now I iterate over the keys, means I iterate over 5, 9, 13, whatever it is, okay. And then I add the test case ID here. Self.testCase ID is a global to the class, okay. Self.log file name is a global to the class, okay. So I am creating a log file name. So see, what I am doing is self.datastruct.keys.4. So if you follow this, it is actually the test case name which I had added in the last class, right? So so this is the test case name.log. So here I am creating the log file name. Here I am opening the log file in write mode. That is the name of the log file. I am extracting the log file name anyway there, right? So this one, right? So say this is the test case name, okay. So I am extracting this name and adding a .log, appending a .log extension to that, and then I'm opening it as in write mode and closing it, so that if it has previous logs, it will newly create the file. Okay, and then I'm opening it in append mode now. Now when I'm doing self.log.open in append mode here, okay, what is happening is that self.log that you have is a global now. So this file handle is getting stored globally until I close it. So when I actually do a log result here, basically self.log.write, that file handle is getting transmitted to here through the global variable, right? So I don't need to bother. The test case does not, rather the test case doesn't need to bother which log it is writing to. Then you have the test script name, self.data struct keys one. So this again is the test script name, which okay, so this is the core of this part. So self.datastruct.keys.1 is this one, 0 1, right, case1.py. So it is extracting the name from the data structure here. Okay, then I'm doing a try, that is I'm just attempting to open that file. Once I open the file, I'm doing a read of the file. Okay, now there's an interesting point here. Even though I'm writing the test cases in a .py file, it need not be a .py file, it may be a .txt also, because my job is basically just to extract all of those values, rather all of the code that is there, doesn't matter what file it is in, and push it into exec. That's all, right? So but still making it a .py file, you can say, it adheres to the convention, okay, that your script is also in py. But if you want to do your scripts in .txt also, it doesn't matter, it will nevertheless work, provided that script is sane. So when you are, as I had said, developing those scripts, you must have it in .py, right? Because it will run as a, probably it will run as a .py there, so standalone. Okay, but here it doesn't matter. So I'm doing an exec, that this exec is actually what is running those scripts, the data scripts, and it is calling the logs, and it is uploading the results and everything. If in the test plan 2 you saw that some problem with script execution because they were not there, this was the exception that was handled. And then I'm closing the file handle after I'm done with the complete run, that is one key. So I run it for all the keys, repeat the process, and thus you will see that the test cases, test results get populated into the TestLink, and the log files get populated. Everything is getting done here. Okay, so that is how this test automation framework works. I hope I've been able to explain it properly, and I hope you enjoyed the demo. Thank you very much.